Hi, this is Muhammad Ramadan from NinjaSec team. In this video, we will talk about Windows security overview for penetration testers. Windows 2000 strengths of Windows 2000 provided the foundation architecture of many of the modern operating systems. Introduction of security technologies such as EFS, PKI, SSL, and SSO. What is the weakness of Windows 2000? Weakness unsupported by Microsoft. Does support newer software including internet browsers. Internet Explorer has been a highly targeted application. Internet Explorer and Windows Explorer were a tightly integrated suite of applications, meaning that vulnerabilities for IE would present vulnerabilities to the target operating system as a whole. Okay. Windows XP. What is the strengths of Windows XP? Strengths requires a less resource than more modern operating systems, considered to be stable for most tasks and applications, backwards compatible with older versions as well as newer versions. Weakness. So the weakness of Windows XP. Weakness doesn't include many security enhancements modern Windows systems have implemented, such as a memory protection, outbound firewall rule sets, and etc. Nearing end of life cycle, vendor will no longer support XP in the near future. Discovered security vulnerabilities will remain unpatched after end of life cycle or EOL. Okay. Password recovery is easier due to password storage method. Okay, cool. Windows Service Pack 2 or SB2. Windows Service Pack 2 added major revisions to how Microsoft Windows addressed security. WPA support. Connecting to wireless networks is a more secure manner. Pop-up blocker tried to combat adware and unwanted pop-ups. Windows firewalls enabled by default, easier to configure. And Windows Security Center enabled management for Windows updates, Windows firewall, and antivirus. Okay. Windows Server 2003. Strengths of Windows 2003. First real attempt to lock down the operating system by disabling services by default. Many services used to be enabled for usability. Robust checklists and security configurations have been released and tested from various organizations, and it is well documented features. Weakness of Windows Server 2003. It is based on Windows XP, which means many of the architecture and security flaws also exist in Windows 2003 Server. Nearing end of life, vendor will no longer support Server 2003 in the future. Discovered security vulnerabilities will remain unpatched after EOL or end of life cycle. Okay, cool. Memory protections in Windows. We have many memory protections like address space randomization layout or ASLR. Randomly organizes positions of memory locations such as the stack, heap, libraries, and executable. We have also data execution prevention or DEP. Prevents applications from running code from non-executable memory locations. It is available in most operating systems or modern operating systems today, like like Vista and Windows 7 and Windows Server 2008. Attempts to combat buffer overflow attacks, so it will stop many buffer overflow exploits from being running. Save execution handlers or save SEH provides a whitelist of addresses for authorized handlers for a particular application. Okay, so we have many memory protections to make exploit development much harder for exploit developers. Okay, cool. User account control. Goal is to apply to concept of least privilege and only elevate privileges when necessary. Normal user accounts will run as a non-administrator, okay, when programs are executed in the context of the standard user, the program doesn't have access to administrator level privileges. Think malware, malware. Some tasks that trigger user access control, installing devices or programs, changing many security settings, modifying user accounts, running many administrative system tools. Windows Vista. Strengths of Windows Vista. LM hash storage is disabled by default. Introduced many management, security, and interface enhancements. Indexing of files and directories for faster search results. Okay, what is Windows Vista weakness? Weakness of Windows Vista considered bloated. Amount of pre-installed software is abundant. Memory protection features in ASLR and DEP were flawed. User account control implementation, often burdensome and labeled as annoying to most users. Okay, resource intensive, so it is slow on many PCs. Okay, Windows 2008. Strengths of Windows 2008 brings user access control or UAC to the server platform. Okay, BitLocker, full disk encryption for data at rest, enhancements to the encryption file system or EFS, granular control of the software firewall, introduces native virtualization technology, support for recent server software packages such as IIS 7.0, fixed limited connections to web server from previous versions. Okay, that's good. So what is weaknesses of Windows Server 2008? Okay, may break support for interaction with legacy devices. All security features and lockdown methodologies have not been well vetted due to the adoption and length of time consumers have had to use it. Previous versions have had much more time for users to develop best practice. Okay, and we have Windows 7. Strengths of Windows 7: similar UI or user interface, security and management enhancements from Windows Vista, optimized so as not to require as many resources, this is light on your PC, removal of software considered as a bloatware, user access control, notifications scaled back and only presented when action must be taken. Okay, refinement of BitLocker, a full disk encryption utility introduced in Windows Vista. AppLocker not lets administrators lock down which applications can be run via group policy or GP. What is the weakness of Windows 7? Must be tweaked to work with legacy versions of Windows and other applications. Okay, let's talk about vulnerability types. We have remote code execution or RCE. Upon successful exploitation, the attacker can execute commands on the target system. We have also denial of service. A successful exploitation of this vulnerability will discontinue usability of the service or application, known as DOS. Okay? Buffer overflows. Once exploited, the vulnerability will allow code to be injected in memory that is not allowed or not allocated for the running process. Okay? Race conditions. When two or more processes race to influence an event of output. Access control failure to enforce a permission. Information disclosure. The application leaks information that may be leveraged for further attack. We have also Windows server-side vulnerabilities. Vulnerability that doesn't require any user interaction when exploits. Okay, just type enter and you own the full system. Okay, once exploited, usually allows for system level access, especially on aerial Windows operating systems like XP and Windows 2000. Major server-side vulnerabilities have been identified as less as more security protections are implemented. Okay. Compare Windows 2000 Pro server-side vulnerabilities vs Windows 7 server-side vulnerabilities. Partially due to the amount of time attackers have had to analyze the operating systems. Although server-side vulnerabilities are often less vulnerable in later versions of Windows. So you don't see many server-side vulnerabilities in Windows Server 2008 and Windows 7, often considered critical by Microsoft when announced. We have native Windows application vulnerabilities, client applications and server applications. Vulnerabilities in client applications, we have Internet Explorer, including add-ons tied into Explorer.exe in older versions of Windows. Also, we have Server Message Block, or SMB, facilitates communication across internal network, like file sharing. Office suite found in many organizations, and it is highly targeted, like Microsoft Excel, PowerPoint and Word. We have server applications vulnerabilities, web services, IIS. Older versions have less protections as with the operating systems. Domain name service, or DNS, useful for gathering information and enumerating targets. Dynamic Host Configuration Protocol, or DHCP. Verifying vulnerabilities. Clients will often request a verification of detected vulnerabilities from a scan to identify for any compensating controls. The use of exploitation frameworks will allow for some pre-configured vulnerabilities to be verified. The penetration tester must have a system for testing vulnerabilities quickly in a short judgment window. Publicly available exploit websites assist in this effort. Okay. Common third-party applications for exploitation. After many assessments in large network systems, the penetration tester will gain an understanding of common applications. This list will change over time. Okay. Common applications currently targeted, like Java, recently became the #1 exploited third-party application. Adobe Acrobat and Adobe Reader, primarily for the extra features that are above and beyond reading a PDF. Okay, and we have also QuickTime accepts multiple formats, which allow code execution, alternate browsers like Firefox, Google Chrome, Opera, Safari. Users and permissions. User accounts are used to log in to Windows systems and access resources. User accounts in Windows can have very granular access control set. Generally, permissions are set by groups and only granularly set for the file systems. Default local user accounts. We have many local accounts found in Windows by default, like system. Local account that has all access to Windows, like root in Linux. We will talk about it later. Administrator. Default administrator account installed with Windows can't be removed. Guest limited account disabled by default. And iuser _ machine name allows anonymous access to IIS web server. Groups. Groups issue a predefined set of permissions to a user, allows an administrator to assign permissions in bulk. Notable default groups like administrators, guests, local service and power users, remote desktop users, and users, as you can see here. Domains and Active Directory. In Windows environments, hosts are generally grouped in domains and forests. Domains and forests can be thought of as groupings of hosts under a single administrative control. Domain provide centralized user accounts, grouping, workstation control, security policies, and more. Forests are essentially a hierarchy of domains. Microsoft implemented Active Directory starting with Windows 2000, which is an LDAP based directory service. Terms, we have many terms. Sites or subnets, a geographic location that hosts networks. Okay. Objects, resources like printers and devices, and principals like hosts and users. And we have domains, a grouping of objects. We have also trees, multiple domains linked by trust relationships. Okay. And we have forests, a collection of trees that share policies and logical structure. Everything in Active Directory is managed from Domain Controller or DC, a prime target of any computer network attack. Cool. Active Directory trusts. Trusts allow separate domains or directories to form inter-domain relationships. A trust simply allows for the possibility of access between domains. Administrators must go the extra mile and actually enable access. Okay. Trusts can be a method for an attacker to jump from one network to another. Trusts come in three parties. One way, only one domain trusts the other. Two way, both domain trust each other. Transitive domain A trusts domain B, and domain B trusts domain C. So domain A trusts domain C, as you can see here. Domain A trusts domain B. Okay, so there is a trust relationship between domain A and domain B, and domain B trusts domain C. Then domain A trusts domain C. Okay. Domains and Active Directory. Let's take a look here. Domain 1, and here may be one way or two ways trusts. Here this domain trusts this domain, or this domain trusts this domain. Okay, or both trust each other. Here you can see subdomain, first one, two-way transitive trusts, as you can see here. Windows File System Overview. The new technology file system, NTFS, is the standard file system for all derivations of Windows NT based operating systems. Superseded the FAT default file system for Microsoft Windows based clients. Okay, FAT file allocation table. Security benefits of NTFS include access control lists or ACLS. The operating system attaches a security descriptor to each file that allows granular level permissions control for every file. Okay. Prior to a process accessing a file, the system checks to see if the process is running under an account with permissions to that file. Active Directory based permissions. File permissions can also be assigned to network users via Active Directory. Let's take a look at basic Windows commands. Gathering information through the file system. Dir lists all files and directories in a directory. Will take a directory path as a parameter. Let's take a look here. Just type dir. You'll see here many directories. CD changes directories. Let's change directories to CD users or CD videos, and we have successfully changed directory from Mohab directory to videos directory with using cd command. Type here displays the contents of a file. Let's view a content. No content here. Can go back to the previous directory with cd space dot and hit enter. Let's view files. Let's try to view this one, ovbn tray.log here. Just type O, then hit tab. So it will automatically give you many options like open VPN tray and open vpn-connect.json. So let's view this. Like type open vpn tray.log, hit enter, and you can see the contents of this file. This is a log file, so you have can see many errors here. You can stop being used by hit Ctrl and C from your keyboard. We have also find command searches for a text in a file. Okay, let's try this command. Find. I want to find a string called no in ovbn tray.log. You can see here find parameter format not correct. As you can see, because we must specify a string by typing no, then specify this, and you can see here it finds all no in this directory here, as you can see here. Okay, let's try another option or command called find str. Offers more powerful options. Let's try this one, find str or find string. Let's view help this command, as you can see here, by type slash and question mark. You can view command options here. Okay, we have also another command called attrib. Displays file attributes, read only, hidden, or system attributes. Let's try this one. Here you can see all file systems attributes here. A as archive, and S for system, and H for hidden, as you can see here. Okay, you can manipulate files at attributes by using attrib command here. You can view other options here, so you can manipulate files with this option from command line. We have also a nice tool called CACLS, or displays access lists for the file. Let's try to go to Windows directory, but first let's go to C directory here, or C partition, and go to Windows directory, then go to System 32, then type CACLS and try cmd.exe. You will find here access lists for the file. Here, administrator, system users, trusted installer. Here, let's try calc.exe. You can see here access lists for the file. Okay. How Windows stores passwords. Windows utilizes the Security Account Manager called SAM file located in the registry on the local drive to store hashes of the user passwords. Okay. Access to the registry may be controlled. Multiple ways to subvert registry permissions. Hashes can be in multiple formats. As of Windows XP Service Pack 2, the concept of a system key or sys key was introduced. Let's try this option here, sys key. You will find here that encryption is enabled. Here, protects the SAM registry file from offline access. Fully implemented in Windows XP Service Pack 3, virtually encrypts the SAM file based on a system key. This key can be stored on local disk or remotely. Hash storage on domain controllers is different, but the attack vectors for retrieving the hashes are similar. Windows authentication mechanisms. We have LMHash, a legacy hashing algorithm that was utilized for all passwords in versions of Windows prior to NT. Support continued for backwards compatibility in later versions of Windows, was partially removed in Windows Server 2003 and finally fully removed in Windows 2008 and Windows 7. Still very abundant in many Windows-based environments. Disabled by default in Windows Vista and Forward. Client environment may require support due to legacy applications or systems that cannot be upgraded. Identifying these targets are key. Okay, a password longer than 14 characters will not have a LM hash. If the password is longer than 7 characters, it is divided into groups of 7 characters and then padded to 14 characters. Okay, therefore when breaking the password, the attacker has to focus on a maximum of 7 characters. So our limit is 7 characters. When storing the hash, all letters are converted to uppercase, greatly reducing the possibilities of each character of password. No use of cryptographic salt or an input to a one-way function that randomizes the output. A password will always correspond to the same hash value. Okay. NT hash, password hashing algorithm which was developed developed in response the security issue found within the LM hash. An MD4 hash of the password can be up to 256 characters, includes upper and lower case numbers and special characters. Because of these modifications, the hash cannot be easily cracked. Okay. LM or NTLM version 1 challenge and response. The protocols are similar to a TCP connect three-way handshake. First, the client requests to authenticate, then server sends a challenge to the client, then client responds. Okay, like TCP three-way handshake. Okay, once the client receives the challenge, it creates a response using the following process. The LM hash or NT hash is padded to 21 bytes. The hash and the challenge string are split into 3 parts. Each hash part is used as a DES key to encrypt a corresponding challenge part. The response is then sent back to the server. Okay. Note that the process is the same for LANman or NTLM version 1 challenge response. The only difference is that LANman uses the LM hash and NTLM version 1 uses the NT hash. Okay, so in LANman use LM hash, NTLM version 1 use the NT hash. Okay, cool. NTLM version 2 challenge response. Note that is NTLM version 2, not version 1. Okay, designed to introduce complexity into the authentication protocol as a response to the previous weakness found in the LANman NTLM version 1 challenge response protocol. In addition to a server challenge, a client challenge is introduced. Methods for formulating the server response has changed. Two hashing algorithms now implemented. Cracking the hash is much more resource intensive and therefore slower. The client response to is formulated by using the NT hash and HMAC MD5 key to encrypt the username and domain name called the NTLM version 2 one-way function or OWF. The OWF is then used as a HMAC MD5 key to encrypt the server challenge, the time stamp, the client challenge, as well as the additional information to form the NTLM version 2 response. Okay, cool. Kerberos authentication utilized in Windows domain environments since Windows 2000. It consists of 3 components: the key distribution center or KDC, the client, and the server. Okay, the KDC handles the Active Directory authentication and employs a ticketing system. The authentication is performed through the authentication server AS of the KDC. Okay, upon successful authentication, an encrypted ticket to get tickets TGT is issued to the client. The TGT is then used to get the final service ticket. The service ticket is used to authenticate to the server and establish a session. Okay, clear? Cool. We have some reference here. You can read here about Windows UAC, User Access Control, through Microsoft, and Windows Wikipedia entry about Windows NT and Windows 2000. Thank you.